Hello and welcome. In this second video, I'm going to work through the exam question for forces that are connected on objects that are connected. Now, in this case, the objects are moving along an incline. So it's important that you read the question and then you are able to break it down again into components or into parts, and then you calculate the F net. So the question reads, this is taken from a November 2015 question paper from the grade 11 question paper. It says in the diagram below, a 2 kg block is connected to a 1 kg block by means of a light inextensible string. So take note the importance of the nature of the string. It is light, it is inextensible, and it's a string. The reason why it is light is because you don't want the string influencing the mass of the system. It's inextensible. It means it doesn't stretch. It maintains its length. So when the objects begin to move, all the force that is applied is just used to exert the necessary force or the tension on the system and get the system moving. So it's very important to remember that. The blocks are pulled up an inclined plane, which forms an angle of 28 degrees to the horizontal. So in other words, there are going to be components, and the components here that are actually going to be affected are the components of the weight and how it splits and breaks down into the various components that are going to affect it. On the FG perpendicular and the FG parallel. Very important. The sides of the blocks which touch the inclined plane have the same area. In other words, that portion that's in contact with the block is going to be the same as that. So that means the force of friction acting on them is going to be acting over the same surface area. The kinetic frictional force between the 1 kg block and the inclined plane is 4 newtons, while the kinetic frictional force between the 2 kg block and the inclined plane is 8 newtons. Draw a free labeled body diagram showing all the forces acting on the 1 kg block. So you're not being asked to draw the force diagram that is acting on both of the objects, but it's just on the 1 kg block. So you're supposed to draw that free body diagram, and that free body diagram must be labeled. Remember, you will not score any points if you do not label the free body diagram. All right, so the first thing that you're going to look at is to say, okay, fine, there's our 1 kg block, so we're going to show it by means of a dot. So make sure that your dot is nice and big so that whatever forces that you may have, they can be clearly represented. Use a ruler, right? So you've got the first force that you have is your applied force. That applied force is 30 newtons. So that 30 Newton force acting in that direction. And then you also have forces that are going to act along the plane. So the forces that are going to act along the plane, the first one is going to be the tension force, right? Which is on the string. And you are also going to have the frictional force. So that's it. So in fact, you're going to have the tension and the frictional force that is also acting along the plane. So this here is your kinetic friction that's acting there. All right, and then the other forces that are there is the normal force, and the normal force is at that force is 90 degrees to the surface. That's your Fn, or your normal force. And then you've got your component, which is your F, not even the component, which is your Fg, right? So your Fg, as it is represented, I have not resolved it. If I had resolved it, I would have to bring in your Fg parallel and also your Fg perpendicular. So in this case, I've just given the net force or the resultant Fg which acts vertically downwards. So these are the forces that are there, and you would get a mark for 1, 2, 3, 4, 5 for those 5 forces that are given. Right? You can actually include the value of the Fg, of the Fk, because you are told that it's 8 newtons, but you will obviously use that when you start doing your calculation. Then the next question says, state Newton's law of motion in words. So it says Newton's law of motion in words, simply put, states that a body will remain, Newton's law states the second law, not the first law. So Newton's second law, it's important that you state it correctly. It says when a net force is applied on an object of mass m, it accelerates the object in the direction of the net force, right? And the acceleration is directly proportional to the net force. So it's important that you remember that the acceleration is directly proportional to the F net, and that the acceleration is inversely proportional to the mass. Right? So when a net force is applied on an object, it accelerates the object in the direction of the net force. The acceleration is directly proportional to the net force and inversely proportional to the mass of the object. So very important. And then the next thing that you are going to be looking at is 4.1.3. It says calculate the magnitude of the tension in the string connecting the blocks. We want to calculate the magnitude of the tension in the string that connects these blocks. So here what you're going to do is you need to look at all the forces that are acting on the object, and then from there you calculate the value of the tension that's there. So you on the 2 kg block, okay, here we can actually draw the free body diagram as well on the 2 kg block, so that you can actually see what is happening. There's the tension, and there is Fg, and then you've got the frictional force acting in that direction. So your Fg is acting downwards, and then you've got your normal, and then so that's the tension. This is your frictional force, or your Fk, acting in that direction, and then that's Fg. And then now you're you are going to calculate the magnitude of the tension in the string. So what if you look at the 2 kg block, we can start looking at the component at the so let me just I'll just cut this here. Now just first, right, oops, I need to draw. No, I can't. I must then redraw that. Right, I will just, so this is the 2 kg block. And then the 1 kg block, you had that. So there's the F, there's the tension, there's the friction, there's the normal, and then there is that Fg. So this is the 1 kg block. and that's a 2 kg block. So the first equation at 1 kg mass, you have the F net is equal to MA. So the F net of the system is calculated as follows. So the F net is equal to F minus, so it's going to be equal to F minus T plus Fk, and this is going to be equal to your MA. So in this case it's going to be 30 minus T minus plus Fk, and our Fk, but there's the Fg, the F parallel, so minus Fg, so this is going to be Fg sine the angle, which is 28, plus or minus plus the frictional force on the 1 kg block, which is going to be equal to 4 newtons, plus 4 in the negative is equal to 1A. And then so this is going to give you a total of 30 minus T plus the Fg, which is going to be, so Fg is equal to mg sine theta. It's 1 kg times 9,8 sine 28, and then plus 4 is equal to A, and so this would become 30 minus T, and then 9,8 sine 28 plus that is equal to 9,8 sine 30, 9,8 times sine 28, 4,6, so it's minus 4,6 plus 4, or minus 4, minus 4 is equal to A. So this is going to be equal to 30 minus 4,6 minus that, so 30 minus 4.6 minus 4, 21,4. So 21,4 minus T is equal to A. So this is equation 1. And then for equation 2, at 2 kg mass, what you're going to observe is the following, that the mass, so it's T minus Fk minus Fg sine theta. So it's F net, so it's going to be F net is equal to MA, and then it's going to be T minus Fg sine 28 plus Fk. is equal to MA, which is 2A. So T minus 2 times 9,8 sine 28 plus 8 is equal to 2A. And therefore, the calculation would give you T minus 17,201. If you put that into your calculator, T minus 17,201 is equal to 2A. So this here becomes equation number 2. So the next thing that you would have to do is to add equation number 1 and equation number 2, and then you can work out the value of T and then also the value of A. So when you add equation 1 and equation 2, so add equation 1 plus equation 2, what you're going to get is 21,4 minus T is equal to A, and then minus 17,201 plus T is equal to 2A. When you add the two equations, it's going to be 21.4 minus 17.201, 0.201, that gives you 4,199. So this here is going to be equal to 4,199 is equal to 3A. So the T's add each other out. Minus T plus T is 0. So you've got that. Then when you divide that by 3A, both sides by 3, what you're going to get divided by 3, you're going to get 1,399, which is the same as A being equal to 1,4. So the value of A is going to be equal to 1,4 meters per second squared. You then substitute into equation 1 to determine T. You can substitute into 1 or 2, doesn't really matter. So if you substitute into equation 1, which is that, so you'd have 21,4 minus sub A into 1. 21,4 minus T is equal to 1,4. So the value of T is going to be equal to 21,4 minus 1,4. The answer is going to be equal to T, and then this is T is going to be equal to 20 newtons. So the value of T is equal to 20 newtons. Now, question 4.1.4. So we've calculated the magnitude of the tension, the string connecting the blocks. The two blocks are interchanged so that the same 30 Newton force is now acting on the 2 kg block along the inclined plane as shown. So you just simply direct swap, same forces, same angles, same everything, but now it's the 2 kg block that is on top, and then the 1 kg blocks at the bottom, and then this thing. So now you're asked to give the qualitative view. So you analyze and you give a qualitative view of what will happen when there is this change. How will the acceleration of the system change? Write down only increase, decrease, or remain the same. So in this case, what happens, how will the acceleration of the system change? The same forces pulling up, the tension is going to be the same, the friction is going to be the same, and therefore you would expect that the whole acceleration of the system should remain unchanged, right? So it remains the same. How will the tension in the string connecting the two blocks change? Write down only increases, decreases, because now what's going to happen is that now this force, that is the tension due to that's acting on this, obviously is not going to be the same, because this the weight of that pulling downwards is going to be less than what it was before. So therefore the tension on this system is going to actually become less, so it decreases. And in the diagram below, a 1 kg mass and a 2 kg mass are connected by an inextensible string of negligible mass. We have explained this to you before, that by virtue of the string being inextensible, it means it doesn't stretch, and it also doesn't have mass, so therefore it doesn't affect the mass of the whole system, and also going to not affect friction and etc. The string is passed over a light frictionless pulley, so the pulley itself doesn't, so the pulley works perfectly and there's no friction due to the that's acting on the pulley to affect the whole system. So the mass, so that the masses hang down as shown. Initially the system is held stationary, so in other words it's not moving, it's kept in its position. Draw a label free body diagram showing all the forces acting on the 2 kg mass. So when you look at the system, you want to look at all the forces that are acting on the 2 kg mass. So when you look at that, you can observe that there's going to be there's the weight of the block itself that acts downwards, and then there's also the tension that that is acting on that system. So when you are now going to represent the free body diagram, so you've got the object, remember, make it nice and clear. There's the object represented by means of a dot, and there is the weight, which is the Fg, or the weight acting downwards, and then there is the tension, which is acting in a upwards. So that is the tension that's acting upwards. Even when you draw it, what you need to show that, you know, the Fg and T are going to be the same, and then the system's not moving. So there is a tension that is represented there. And then the next item, 4.2.2, calculate the time it will take the 1 kg mass to move a distance of 1 meter when the system is released. Calculate the time it will take the 1 kg mass to move a distance of 1 meter when the system is released. So in this part, there's obviously going to be some movement. The whole system is going to begin to move, and so you will have to go back to look at what the acceleration of the system is going to be. When you've determined that acceleration, you will also be asked to determine the time it takes for it to cover a distance of 1 meter. So from there you would need to go back again to the equations of motion, apply the appropriate equation, and you should be able to solve that. So the first, so basically what you would need to do is, the first thing that you're going to do is to say, okay, what's the F net of the system? The F net is equal to MA. So for the 1 kg block, so you just use the 1 kg block. So at 1 kg block, so what's the F net? The F net is going to be the T, which is going to cause the acceleration. So T minus the Fg, so which is equal to mg, which is t minus 1 times 9,8, and then that whole system is going to be equal to 1a, and therefore t minus 9,8 is equal to a. That's equation number 1. And then equation number 2 is what happens at the 2 kg block. So what's going to cause the acceleration? It's the weight. So the weight minus the tension is going to cause the acceleration. So it's so it's going to be 2 times 9,8. So that's mg minus t, which is going to give you 2a. So from there, 2 times 9,8 is 19,6. Minus t is equal to 2a, and then this is your equation number 2. So from there you can now work out the value of t and a, so it doesn't matter which one you solve first, but if you add equation number 1 and 2, add 1 and 2, what you're going to have is t minus 9,8 is equal to a, and then you're going to have minus t plus 19,6 is equal to 2a. And therefore, when you add those two, t minus t, so t plus minus t is equal to 0, minus 9,8 plus 19,6, it's going to give you 9,8 is equal to 3a. Divide both sides by 3, and that is going to, your a is going to be equal to 3,27 meters per second squared. You can verify that by putting it into your calculator. So now that you've found the acceleration, you can then calculate the time for it to move a distance of 1 meter. So the equations of motion that allow you to relate time and distance, you have delta x. I'm just going to remind you the equations that allow you that delta x is equal to vi delta t plus half a delta t squared. You know the distance, you know the initial velocity, you want to calculate time, you know the acceleration, so that this equation is good enough. So what's the distance? The distance moved is going to be 1 meter, and that distance is moving in the upward direction. So if we take our upward direction to be negative, and what we are going to get is that acceleration, or that delta x is going to be minus 1, is equal to your initial velocity. This object was stationary, so its initial velocity is 0 multiplied by t, so anything multiplied by 0 is 0, plus the acceleration of the system is equal to 3,27, so it's going to be accelerating, so it's plus half multiplied by 3,27 multiplied by delta t squared. So that is what you have, and then from there you just multiply out and then find the value of delta t. So half of 3,27, so 0.5 times 3.27. 3.27, half of that is equal to 1,635, so minus 1 is equal to 1,635 t squared. So if you divide everything by 1,635, and then oh yeah, the acceleration here, since it's moving also in the vertical upward direction, is going to be negative. So it's going to be minus 1,365. So divided by 1 minus 1,365. So times the acceleration here, it's going to be in the upward direction. So it's 3 minus 3,227 moving upwards. So what's going to give you is 1 divided by, so the inverse of that is going to give you 0,611, and then we want the square root of that answer, which is going to be equal to 0,78 meters per second squared. So your t is equal to 0,78 seconds, not meters per second squared, but the seconds squared. Remember, your acceleration, this object is moving upwards, and therefore the acceleration will become negative, because we've said let our upward direction be negative. So if we're looking at it from the position of the 2 kg block, it's going to be moving in the positive direction. So in that same time, it's also going to move that same distance in the same time. All right, thank you for watching. If you like this video, please share your comments, subscribe, and share it with amongst your friends. Send your comments, we'll be grateful for that. Thank you so much. Till the next one, bye bye.